So let's look at some examples. We have each piece again, so we can break it up. We have the cubed root of negative 27. We have the cubed root of x to the 7th. We have the cubed root of y to the 3rd. And we have the cubed root of z squared. So the cubed root of negative 27. So because we have a negative inside, that means that we're going to have a negative on the outside. So equals negative. The 27, if we break down 27, we get 9 and 3, and then 3 and 3. And remember, we're looking for cubed roots, so we're looking for groups of 3. So there's a group of 3 3's here with nothing left over. So the cubed root is just going to be negative 3. With the cubed root of x to the 7th, 7 is not a multiple of 3, so 6 is. So 6 divided by 3 is going to be x squared, and then we have a cubed root of x left over. 3 is a multiple of 3, so this is just going to be y. And then the cubed root of z squared. So since 2 is not greater than or equal to 3, it's going to stay exactly the same. So again, we'll put it all together. Everything on the outside stays on the outside. So negative 3, x squared y. On the inside, we have the cubed root of x z squared. Okay, now with the second one, let's do the same thing. So we're going to do the cubed root of negative 32. We're going to do the cubed root of f to the 6th. We're going to do the cubed root of g to the 5th. And we're going to do the cubed root of h squared. So 32, we're going to break down. So we can break it into 8 and 4. 8 would be 4 and 2. 4 would be 2 and 2, and 2 and 2. So I'm looking for groups of 3. So here's 3 of the same. And then I have these 2 that are left over. So the group of 3 is going to come out as a 2. And I'm going to take out that negative. So negative 2. And then I have 2 2's left. So that means I have a 4 left on the inside. The f to the 6th is a multiple of 3. So I'm going to divide 6 by 3, and I get f squared. G to the 5th is not a multiple of 3. So the closest multiple would be 3. So 3 divided by 3 is going to be g. And that means I have 2 left over. So g squared on the inside. Cubed root of h squared, since 2 is not greater than or equal to 3, I'm going to leave that exactly the way it is. So we're going to put together everything on the outside. So I have a negative 2, f squared, g. And then on the inside, I have a 4, g squared, h squared. Okay? Now this rule for, the multiples of 3 and the square roots and all that stuff, it's going to be the same for other roots with variables. Okay, so basically when we had the square root, we had even and odd. But that was basically multiple of 2 and not multiple of 2. So for cube roots, we had multiple of 3 and not multiple of 3. So any other possible roots that we can have, whatever indexes we can have, same rules are going to apply. So if I had the 4th root of x to the 8th, I want to be able to divide 8 by 4 because it's a multiple of the root, so that's going to give me 2. Okay, if I have a 5th root, so my index is 5, and I have an exponent that's a multiple of that root. I'm going to divide 20 by 5, and I get x to the 4th. If I had something like a number, so if I had like the 4th root of, actually, I'm going to skip that and come back to that in a second, because I don't want to confuse people. Alright, so just leave that like that for now. So not multiples of the root. So if I have like the 4th root of x to the 10th. So 10 is not a multiple of 4, but I'm going to come to the closest multiple of 4. So that would be like x to the 8th, and then I have 2 left over. So x to the 8th is going to become the 4th root of x to the 8th is going to become x squared. And then I'm left over with the 4th root of x squared. Okay, so you can skip that middle step. I'm just putting it there for explanation. So if I have like the 5th root of x to the 24th. So since 24 is not a multiple of 5, the closest multiple of 5 would be 20. So if I break it into x to the 20 and x to the 4th, so the 5th root of x to the 20th, 20 divided by 5 is going to give me x to the 4th, and then I have this 5th root of x to the 4th left over. If you have numbers, so if you're trying to find, so this is something separate, if you're trying to find the 4th root of 126, okay, you're looking for groups of 4 when you break things down. If you're trying to find the 5th root of 1025, you're looking for groups of 5. Okay, so not the number 5, just groups of 5 of the same number. So whatever the index is, that's how many you need. So when it was a square root, you were looking for pairs. When it was a cube root, you were looking for groups of 3. If it's a 4th root, you're looking for groups of 4. If it's a 5th root, you're looking for groups of 5, so on and so forth. So if we look at these, we can break each one down. So x to the 8th, if I can divide that by 4, so this is just going to be x squared, and then 12 divided by 4 would be y to the 3rd. There's nothing left over, it goes evenly, there's my answer. The 4th root of x to the 20th is going to be x to the 5th. I'm dividing 20 and 4. The 4th root of y to the 28th, 28 divided by 4 is going to give me y to the 7th. Okay, so here we have 12 divided by 4 is going to give me x cubed. 16 divided by 4 is going to give me y to the 4th. And with the last one, we have a number. Okay, so 32. If we break 32 down, 16 and 2, 8 and 2, 4 and 2, 2 and 2. Again, can't use 32, 16, 8, or 4. We're looking for groups of 5, since my index is 5. So 1, 2, 3, 4, 5, here we go. We have 5 2s. So that's just going to come out as a 2. If there is anything left over, same rules. Whatever's left over goes inside. So 2 is outside. We can divide 10 by 5, so we'd have y squared.